Welcome to Master Mathematics in Minutes. Today's topic is about the arc length, and we'll cover a couple examples on how to calculate the arc length. And we will conclude the topic with a summary. And finally, be kind and subscribe for more videos. So, what is the arc length? The arc length is a fraction of the circumference of a circle. Visually, we have a circle with radius r. We also have the angle theta, as well as the arc in red. So the arc length is equals to 2 pi r multiplied by theta over 360 degrees. So the circumference of the circle is 2 pi r, and the arc length is a fraction of that. So that explains why we multiply by theta over 360. In the first example, we're asked to calculate the arc length below. We're given a circle with a radius of 8 centimeters and theta of 125 degrees. And we're asked to calculate the arc length in red. So, the arc length is equals to 2 pi r, which is the circumference of a circle, multiplied by theta over 360, because it is a fraction of the circumference of a circle. And that is equals to 2 pi, and we'll replace r by 8, because the radius is 8, multiplied by 125 degrees, which is theta, over 360. And that gives us 17.45 centimeters. In the second example, we're asked to calculate the arc length below. Visually, we have a circle with a radius of 2 centimeters. And we're given that theta is equals to 220 degrees. And we're asked to calculate the arc in red. So we have arc length is equals to 2 pi r multiplied by theta over 360. And that is equals to 2 pi. And we'll replace r by 2, because that is the radius of the circle, multiplied by theta, which is 220 over 360. And that is equals to 7.68 centimeters. In the third example, we're given the arc length and radius are 52 centimeters and 9 centimeters respectively, and we're asked to find the angle of the arc. So we have arc length as equals to 2 pi r multiplied by theta over 360, and we'll set that to be 52 centimeters from the question. So copy 2 pi down. We will replace r with 9 from the question above, as being the radius, multiplied by theta over 360, and we'll copy 52 down. And solving for theta, with theta as equals to 52 multiplied by 360 over 18 pi, and with theta as equals to 331.04 degrees. So visually, we have a circle with a radius of 9 centimeters. And we're given the arc length is 52 centimeters in red. And we found theta as being equals to 331.04 degrees. In the fourth example, we're given the arc length and angle of the arc are 100 centimeters and 150 degrees respectively, and we're asked to find the radius. So, with arc length as equals to 2 pi r multiplied by theta over 360, and we'll set that to be 100 centimeters from the question. We'll copy the 2 pi r down and multiply that by theta is now 150 degrees from the question above, over 360, and we'll copy the 100 down as well. And solving for r with r as equals to 100 multiplied by 360 over 2 pi multiplied by 150. And that gives us r as equals to 38.20 centimeters. So visually, with a circle with a radius of 38.20 centimeters, which is what we found, and with an arc length of 100 centimeters, and theta is equals to 150 degrees. To summarize, the arc length is a fraction of the circumference of a circle. So we have the arc length as equals to 2 pi r multiplied by theta over 360. Remember, 2 pi r is the circumference of a circle, and the arc length is a fraction of that. And that explains why we multiply that by theta over 360. Thank you very much for watching. This is Master Mathematics in Minutes.